Welcome back to part 2 of the video. Now we're going to multiply powers that have the same base. And we're going to look and figure out a rule on how to deal with powers that have the same base. So what I'm talking about, let's just look here at the example at what it looks like. So here I've got 3, that's just a coefficient, x to the third times 4, x to the sixth. So the 3 and the 4 are just my coefficients. There's nothing different about them. And then my x, my bases, x to the third and x to the sixth, my base is alike. So I need to figure out how to deal with the exponents. So let's see what this really means. If I break it out, what I'm talking about is 3 times x times x times x. That's 3x to the third times 4 times x to the sixth. So that's going to be 6 of these x's. Okay, expanding it out like that is an option, but I'm just showing it to you so you can see what's happening. The rule will make it a lot easier and take up a lot less paper. So what this really is, if I just kind of reorganize everything, I'm going to go ahead and put my coefficients together. So I've got 3 times 4 times, and then I'm going to put all of my x's together. X times x times x times x, 2, 3, 4, 5, 6. Okay, so 3 times 4 is always 3 times 4, it doesn't change, so that's 12. And then my base, how many times am I repeating my base? I'm repeating it 9 times. So if we look for a rule in this, this is x to the third times x to the sixth. I'm adding my 3 plus 6 is what gave me my 9. So my rule is I multiply coefficients like I always have. They're not subject to anything weird. But then I'm going to take my bases. If my bases are alike and I'm multiplying them, I'm just going to add my exponents. So let's just go ahead and do a little bit of practice. So let's look at number 15. Okay, 15, 16, and 17 are going to let you explore using that rule. You can expand it out if you feel like it, just to make sure you're doing it right. But the goal here is to get you to understand what you're doing so you can move to the rule. So I want you to do 15, 16, and 17 on your own. Pause your video and then check back for the explanation. Whether you expanded them out or used the rule or did a combination of both, hopefully you got to these answers. Sometimes students struggle a little bit remembering that this is just r to the power of 1. So that's why I used a 1 right here, 2 plus 1. Okay, number 18, 19, and 20. I want you to practice on those again with the video paused. On number 20, think about it as a puzzle. Find an easy point of entry. Maybe start with the A's. Oftentimes when I'm working on things like this, I will go ahead and remind myself that the A is to the power of 1 and my C is to the power of 1. Because they don't have exponents, I will go ahead and write the power of 1. It just helps me not miss it when I'm adding things up. So pause your video, do 18, 19, 20, and then check back for the answers. Okay, look and make sure you got the right answers or figure out what you did wrong. On number 21, I'm going to have you do 21 and 22 on your own, but before you start 21, remember in our example that our coefficients, we still multiply like normal. So our 4 and our 6 on number 21 are going to be multiplied. So go ahead and pause your video and do 21 and 22, and then check back for the answer. The biggest trick on number 22 is we know we have like bases of a. When we add our exponents, we can't really do much to an m and an n. They don't combine, so the answer is a to the m plus n power. Okay, so our second thing that we're going to work on today is the quotient of powers, which means quotient means dividing. So right up here beside the word quotient, I want you to write the word planet. and then show it to me tomorrow for some candy. Now let's look at what the rule is for dividing coefficients. We divide our coefficients normally like we always do, but if we are dividing bases that are the same, we're going to subtract our exponents. So divide coefficients just like always, but if our bases are the same, then we're going to subtract our exponents. So let's see what that looks like. What we've got here is we've got 12 x times x times x, that's 12x to the third, over 2x times x. So our coefficients, nothing's changed. 12 divided by 2 is 6. Then we start thinking about division. We're really canceling out. Anything divided by itself is just a 1. So the x on top, the x on bottom, those cancel out, really just leaving us with 1x. So our answer is 6x. But just like with multiplication, it's a lot of writing out of variables if we're going to have to expand them. So the rule is we're going to subtract our exponents. So 12 divided by 2 is still 6, just like normal. And then we have x, 3 minus 2. 3 minus 2 is 1, bringing us back to the 6x. So what I want you to do is start practicing using the rule. We are going to run into negative exponents. So on number 24, when you're practicing it with the rule and you end up with a negative exponent, remember from the first part of the video to go ahead and take care of the negative exponent to get your answer. So I want you to do 23, 24, 25 on your own, pause the video, and then check back for the answers. Pretty much as long as you remember to take care of your negative exponents, then you would have gotten number 24 correct. On number 25, same thing, our 6/9 only simplifies down to 2/3, so we still have a 2 on top and a 3 on bottom, and then our x to the negative squared exponent is going to move up on top. So for 26, 27, and 28, I want you to pause your video again, do those, and then check back for the explanation. Okay, check your answers and make sure that you got the correct answers. Number 28, again, just like we had with multiplication, we need to subtract our exponents, but m and n are not like terms, so it just ended up being m minus n. All right, number 29, we'll just do that really quickly together. That's going to be 4 to the 7 minus 3. So that's 4 to the 4th power. And if we go ahead and multiply that out, it's 256. All right, our last one is number 30. That's giving us an application. There's a lot of applications that use exponents. So go ahead and multiply the length times the width times the height and figure out which ones of the answers actually match. Pause your video to do the work and then check back for the final answer. So looking at equivalent expressions, A, C, and D are all three equivalent to our answer, which was x cubed over 6.